Hello everyone, in this video we are going to talk about the Lewis structure of beryllium chloride in the gas phase. To write down the Lewis structure of a molecule, we need to know the total number of valence electrons in the molecule. Atomic number of beryllium is 4 and the electronic configuration is 1s2, 2s2. 1s2 are the core electrons, 2s2 are the valence electrons. Therefore, we have 2 valence electrons from the beryllium. Atomic number of chlorine is 17. Therefore, the electronic configuration is neon, that has 10 electrons, and then 3s2, 3p5. The 3s2 and 3p5 electrons are the valence electrons. Therefore, 7. But we have 2 chlorine atoms. Therefore, 7 times 2, 14. Only 1 beryllium atom. So, therefore, 2 times 1 is 2. This means that the total number of valence electrons that we have in beryllium chloride is 16. So, using these 16 valence electrons, let us try to draw the Lewis structure. Chlorine is more electronegative than beryllium. Therefore, chlorine comes at the end. Beryllium, let us put 2 valence electrons, and then chlorine, we have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. On this side too, 1, 2, 3, 4, 5, 6, 7. These 2 electrons can make a bond pair. These 2 electrons can make a bond pair. Therefore, we can redraw the structure this way. Chlorine and then 3 lone pairs and then 1 bond and then beryllium and then another bond, then chlorine and then 3 lone pairs. Now, let us check whether it satisfies the octet rule or not. The chlorine atom does satisfy the octet rule. We have 3 lone pairs that contributes to 6 electrons and 1 bond pair that contributes to 2 electrons, therefore 8. On this side too, chlorine satisfies the octet rule. However, beryllium atom does not satisfy the octet rule. We have only 4 electrons around beryllium. So, beryllium does not obey the octet rule. So, this is an exception to the octet rule. But still we are not sure whether this structure is correct or not. So, let us check the formal charges. Formal charge is equal to number of valence electrons in the atom minus number of non-bonded electrons, that is lone pairs in the molecule, minus number of bond pairs of electrons divided by 2. Therefore, for beryllium we have 2 valence electrons in the atom minus number of lone pairs 0 minus number of bond pairs, we have 2 bonds, therefore 4 by 2. This means this is equal to 0. And then for chlorine we have 7 valence electrons minus we have 3 lone pairs, that means 6 electrons, minus we have only 1 bond, therefore 2 by 2, therefore 7 minus 6, 1 minus 2 by 2, that is 1. So, therefore, this is also 0. So, the formal charge of chlorine on both ends as well as beryllium is 0. Therefore, this is the best Lewis structure for beryllium chloride. On the contrary, if we do write a Lewis structure like this, let us say if we are writing a Lewis structure like this, thinking that it would satisfy the octet for beryllium, because now we have 8 electrons around each atom. What would happen? Let us calculate the formal charge now. For beryllium, it would be number of valence electrons 2 minus there are no lone pairs minus we have 4 bonds, that means 8 electrons by 2. So, therefore, 2 minus 4, the formal charge will be minus 2 on beryllium. And then for chlorine it would be 7 valence electrons minus we have only 2 lone pairs, therefore 4 minus we have 2 bonds now, therefore 4 by 2. So, 7 minus 4, 3 minus 4 by 2 is 2. So, 3 minus 2, therefore, that is equal to plus 1. So, we will have plus 1 formal charge for each chlorine. Even though the net charge is 0, but still we cannot take this structure as the best Lewis structure, because for electronegative atoms we should not have a positive charge. So, here chlorine is the electronegative atom. Putting a formal charge of plus 1 for that is not a valid Lewis structure. Likewise, beryllium is a electropositive atom, and for that putting minus 2 formal charge is not the best way to represent a Lewis structure. Therefore, the structure that we wrote before is the best Lewis structure, and beryllium chloride is an exception to the octet rule.